This is the last portion of 9-1, the confidence intervals. Now the confidence intervals will be the intervals for the difference between two means. So these are Z confidence intervals. For the difference between two means. So what we're hypothesizing is this null hypothesis, meaning mu1 minus mu2. The question is it equal to 0? Is it greater than 0? Or is it less than 0? Meaning, if mu1 is completely equal to mu2, we will have absolute equality, and this will never happen for any of the problems in the real world. Usually, either mu1 is slightly bigger than mu2, or mu2 is slightly bigger than mu1. Notice, if mu1 is bigger, what you're going to see is you're going to see positive numbers. If mu1 is smaller, you will start seeing negative numbers. So the confidence interval will be bound by the difference between the two samples plus the error. Now the error looks really ugly this time. It's Z alpha over 2 sigma sub 1 squared over n sub 1 plus sigma sub 2 squared over n sub 2. And because I have computers, I can go in here and paste this, copy paste, because it's the same thing on the other side. But with a minus sign. Okay, so this is the formula that is programmed under a two-sample Z interval. This is the formula. What they're asking us to do in this example is find a 95% confidence interval for the difference in the means of the example 9-1 leisure time. So what I'm going to do is I'll actually scroll back up to our leisure time example. That's this one. And all of the necessary statistics are already outlined. And notice that x bar 1 is larger than x bar 2. So what I'm going to see is I should see positive numbers. Also notice that our my hypothesis test showed that we reject the null hypothesis, meaning that we did find significance difference. So 39.6 is much larger than 35.4. What the confidence interval will show me is how big is the difference. Is it maybe just a couple of minutes, or maybe it's hours and hours of difference? If you take a look at this, 39.6 minus 35.4 is about 4 hours. So my point estimate is about 4-hour difference, give or take that error that I need to figure out. So I am expecting all positive answers, and the result, meaning reject the null hypothesis, the result of a two-tail hypothesis test should be exactly the same as a confidence interval, because that one is also two-tail. So notice alpha of 0.05 two-tail is exactly the same thing as running a 95% confidence interval. So let's do that. Under your stats, go over to tests, go down to 2 sample z interval. It should be number 9 if you have the same calculator as I do. 2 sample z interval. Then you have a choice between data or stats. You're going to choose stats. And in order for me to type in all of the statistics, I need to go back to that example and outline all of the necessary statistics. So the sigma 1 was given to me at 6.3. Sigma 2 was at 5.8. Let me scroll up over there. So this is where I'm actually looking, right here. Sigma 1 is 6.3. Sigma 2 is 5.8. X bar 1 is 39.6. We have 35 as your N1. Now notice, if you just ran this example on the calculator, a lot of the things should already be in your calculator, because what it does, it uses the same memory space. This is why it's under the same button stats. X bar 2 is 35.4. N sub 2 is 35. And the confidence level that we're interested in is 95%. I will calculate. After you push calculate, the first thing that you should be writing down is the actual interval. The interval is 1.363 and 7.037. What this means is, because all of the numbers are positive, x1 bar, or let me go like this, mu1 is greater than mu2. So this is what this tells me. That the average, we did find significant difference between the two samples. In particularly, whatever I called sample 1 spends more time on leisure activity than whatever I called sample 2. So for that, I have to go back to my example, and it says, well, it's 26 to 35-year-olds spend more time on leisure activities than the 46 to 55-year-olds. So this is what I'll write down. With 95% confidence, it appears that 26 to 35-year-olds spend more time on leisure activities than what was the age group? 46 to 55. 46 to 55-year-olds by about, and this is where it makes sense to round, and I definitely need units, by about 1.4 hours more to and up to 7 hours more. Let me read this again to make sense, to make sure it makes sense. With 95% confidence, it appears that 26 to 35-year-olds spend more time on leisure activities than 46 to 55-year-olds by about 1.4 hours more and up to 7 hours more. The confidence interval gives me more information than the hypothesis test, but we emphasize hypothesis tests more because sometimes we don't need the information, sometimes we do, but there's more, I guess, work to be graded on the hypothesis test. That's why it's emphasized more in this book. Although confidence interval do project the same information with numbers. But you can do one tail. Although I wrote here one tail, this is actually a two-tail test. I will end this video right here. This is the end of 9-1, and then we'll continue with 9-2.